So now we'll be moving on to the topic of trigonometry. And we'll start by defining some important trigonometric functions: sine, cosine, and tangent. And you may have already learnt some definition for these ones, but if it's SOHCAHTOA, then I'm sorry, but they're not proper definitions. They may be correct, but they're only correct between 0 and 90 degrees. It doesn't work for any other angles. But with the definitions that I'm about to go through now, you can use them for any angle. Obtuse, reflex, even beyond that, and also negatives. So let's get into it. If I draw up a set of axes, and then I draw a circle, and so I've drawn that circle on the axes, and I'll tell you that the equation for that circle is x squared plus y squared equals 1. So that means it's got a radius of 1, and it's got a centre of 0, 0. Now if we've drawn that, I've drawn a radius here, and that makes an angle with the x-axis, and by definition, this point up here will be cosine theta, sine theta. And so that would tell us that this bit here is cosine theta, and then this bit here is sine theta. And so that is our definition of cosine and sine. Cosine is the x-coordinate of the point of intersection of a radius of a unit circle with the circle when the radius makes angle theta with the x-axis. And sine theta is the y-coordinate of what I just said. And we can kind of see how SOHCAHTOA might work from here. Like, if we wanted, let's say we didn't know if this was sine of theta, and so we know that this is our angle, our theta. This will be our opposite, and this will be the hypotenuse. And we know that sine of theta equals opposite over hypotenuse, and our hypotenuse is 1 because it's also a radius. So you get opposite over 1, so sine theta equals opposite. And we can do the same thing for cosine. Will equal adjacent over hypotenuse. So it's just adjacent over 1, which is adjacent. And additionally, it could work for any length of the hypotenuse, not just 1. Because think about it, if we extended this out and made it, we multiplied that line length by some k, then you just, because that would make a similar triangle, you see, common angle, 3 common angles, then you would multiply this by k as well, so that would become k cos theta, and this would be k sine theta. And so when you do that division, those k's will cancel out, and you'll still get cosine theta and sine theta. So I'll just rub this stuff out for now so I can move on to defining tangent. Now, you should know by now that a tangent is something that is a line that touches a curve at one point only. So here I've drawn a tangent at x equals 1, and I've extended that hypotenuse, that radius. And then so this point here, by definition, has the coordinates 1, tan theta. And that's your definition for tangent. Now this unit circle can work for any angle. I could go and do this. Like that theta. It would still be cosine theta, sine theta. I could even, so those are all anti-clockwise rotations. Anti-clockwise rotations give positive angles, but if I could also do a clockwise rotation giving me a negative angle, and that would still give me cosine theta, sine theta. Then up here, I could even go all the way along like this. It would still give me that point of intersection here would still give me cosine of that theta and sine of that theta.